So we need to normalize variation. Yeah, because we know if like this is too strong, so maybe instead of studying the I just study the practice, which so then by the time Irish equivalent, then start to listen. That moment, there it's not that issue. It's but there at least there is at least it's not that hard. And also lately now vibration with
安平，你们刚刚有课啊？什么课？ Okay, let's start. So I put out some criteria here. So these are the screenshot I take when I do a recommendation letter for students. So when they apply for their masters, they ask me to write them a recommendation letters, and then this is what the system show me. Okay, so basically you are judged by these personalities. Okay, so if you can read it, please read it. It's very important. So these are the very important personalities. These are the very important personalities that you need to develop in your university study. Okay, if you go out graduate from uni without these personalities, you're basically wasting your time here. Okay, you're wasting your 3 years, 4 years studying here. Okay, so as a responsible lecturer, I think we need to look into this carefully. So, well, I mean, actually, one of the point here is this. There's one of the very important point here we're gonna train in this course is on. Let me see, integrity, interpersonal relationship. Okay, so how you deal with people. So when you do these projects, group projects, right, you should learn how to discuss with people. Okay, not quarrel with people. Ability to work with others. Okay, so if you can work with others or help each other, okay, it's very important. And among the others, right, you see goal directed, okay, maturity, okay, and then analytic power, okay, judgment. Okay, so these relate to how you deal with problems. If you met a problem, do you give up or not? Or how do you think of a way to solve it? Okay, if you cannot solve it, ability to work with others. Can you work with others to solve it or not? Okay, can you get help from the others or not? Oh, it's very important. This is a real life, practical. I'm not talking about abstract thingy. I need to take one if you write this recommendation letter. Okay or not? These are very important criteria. So if I train a student or class, every day I complain about assignment hard, like that. So how? Huh? You go out, what's the use of you? You are useless. Sorry, I'm very bad. You are useless. Yes, sorry. Okay, I'm not talking about you. I'm talking about everyone. Okay, so you as a university level students, right? Okay, if you don't train to meet difficulty, you don't try to face difficulty. What are use of you here? Okay, understand or not? You understand? You go out as an adult. You need to face world problem. It's not assignment problem. This is world problem. Even harder. Even harder. I got answer for you. Outside, there's no answer one. You understand or not? Okay. It's very important, huh? So look at this every day. Look at this. Put on your wall. Okay, you go sleep, you go eat, you go brush your teeth. Look at this. Do you meet this goal or not? Which category are you in? Which category you are in? Okay. If you want to get scholarship, make sure you are in the excellent category. Okay. Okay. Go back. Read this. This is very real. Every time we want to submit a recommendation letter, this is what we put in. Okay. Okay, so make sure coming class learn as much as you can. Okay, maybe I will put a high expectation of you, but my goal is you need to learn as much as you can. Okay, no matter how. Okay, depend on your abilities. Okay, see which level you reach, and then we will give grade accordingly. Okay, yeah, does it make sense? Okay, so look at this every day. See if you reach this goal. Okay. Okay. I mean, everyone is learning, including me, right? So, learning process is always hard. So we have to get through it. Otherwise, you won't learn. Depends. Maybe some people want to live a normal life. That's their life. But you cannot deny others' life to live a better life. Okay? Okay. Any question from the previous lecture? Any question? So for your projects, right, make sure you meet this week at least once. Okay, you need to record. Okay, record it down. And then try and divide out the word log. Okay, divide out the word log. I think I already told all the master students. So maybe I'll remind you again on Wednesday or tomorrow. Try and divide out the word logs and then make a meeting with me next week. Okay, so why you need to meet with me next week? So make sure your teammates read a lot. Okay, read a lot and then try and brainstorm what topics you want and then try and divide out some words. Okay, to understand the whole topic. For example, a big theorem, let's say the Gaga theorem. Okay, so if you want to understand this theorem, how do we divide works to understand this theorems? Okay, which part of student understand this basic first? Which part of student understand that basics first? And then put together a whole paper in here. Okay, does it make sense? Okay, so try to meet at least once this week. And then next week, you need to tell me what's the possible route you guys want to take. And then we could somehow decide by next week what's your project topics. Okay or not? Okay, so if you can pull out a leader first this week. Okay, if the other workload is not divided yet, so at least pull out a leader first this week. And then, so we need to have a 2 progress report for each group for every week. And then, so the purpose of this progress report is whatever you want to record down inside your progress report, right? You have to justify your workload in the end. Okay, let's say there's anything happening, I need to refer back, and then we know what happened. Okay, when you do the meeting. Does it make sense? Okay. Okay. Okay, so I have if I have a 2 progress report from you each week, then I will have a 2 independent viewer for the same same issue that happened on that week. Okay, so that we can judge can be more fair towards some activity that you have carried out. Any question? Okay. Okay. If no question, right? So the plan of this week is hopefully we can finish out these basic geometry of projective space. We stop at projective 3 space, projective 3 space, and then we will move to algebra, solid algebra on commutative algebra. I think we'll spend around the same time we spend on the basic geometry before we go into algebraic geometry, proper algebraic geometry, which lead to a Hilbert downstairs third. For assignments, right? I feel like I will pull out an assignment after I done a section. For example, if I done the geometry section, I pull out the assignment. I don't want to wait until too much content and I give out an assignment. I scared you will overload. Okay, so once I finish a big chunk of section, maybe I will pull out some assignment. Depends how many weeks I spend on the material. Maybe for example, right? So our aim is like 3 weeks. 3 weeks, about 3 weeks one assignment, right? Okay, so in that case, our assignment content will be about 3 weeks. So let's say this geometry, right, stop at 1.5 weeks. So maybe I will pull out a 1.5 week assignment for you first. Okay, so that they know. How to say? Not在一起的。Stop moving. Squeeze, cramp together at once. Okay, so we split it up. And then I think we will also consider the number of questions to be lesser in that case. Okay, yeah. We'll see how it goes. We'll see how it goes. Because it is really new. The content will be depend on what I researched on every week also. I also research on this topic. You also research, right? So we research together. Okay. Okay. Any question? Question? Okay. If no question, let's quickly recap what we did last time, and then we finish up the proof of projective plane on a completion of a affine plane. So let's talk about affine plane first. So let's talk about affine plane. So affine plane A. Okay. So what's the affine plane A? Is a tuple, right? Okay, it's a set of points and a set of lines. Okay, set of points, set of lines. So you just tell me what are the points, what are the lines. Okay, satisfying how many axioms? Three axioms, right? A1, A2, and A3. So A1 is what? You have 2 points. If you have 2 distinct points, then there exists a unique line that passes through them. Okay, how about second? Second is the guarantee of the existence of a parallel line. Okay, so if you have one line and then a point not on that line, then you will have a line that passes through this point not on that line, which is parallel to the original line. Okay, the existence of parallel line. There's some line that. Okay, yeah. What did I say? Oh, okay, thank you. So I repeat. Sorry, sometimes my hand doesn't want to listen to my brain. Okay, A3. How about A3? There exists 3 non-collinear points. Okay, so there exists 3 non-collinear points. And maybe like this. Okay. There's 3 non-collinear. Okay. And then we define what is called a projective plane. It's the same, still the same. We have a tuple of set of points and then also set of lines. Okay, to differentiate these 2 planes, right? We put a different notation here. But why we put a bar here later will be more apparent. For this P. Okay, P. Okay, so P here satisfy 4 axioms. Hey, where's Jing Seng? Do you call him? Okay, so P1, P2, P3, and P4. You have one more axiom than affine plane. The first one is the same. Okay, if you have 2 different points, okay, then there's only one line that joining them. Okay, it's the same. How about second one? Second one is differentiating affine plane and projective plane already. Okay, second one says what? Any 2 lines must meet at least 1 point. Okay, any 2 lines must meet at least 1 point. So seems like there's no parallelity here already in this basis. Okay, 2 distinct lines must meet at least 1. Not just distinct, non-distinct one obviously meet. Okay, at least 1. P3 still there exists 3 non-collinear points here. That's similar to the A3 from affine plane. And then the last one says that every line must contain 3 points. 1, 2, 3, like that. Okay. So what's the relation between an affine plane and a projective plane? Okay, there's a canonical way to get from affine plane to projective plane. Okay, by taking a completion. Okay, by taking completion here. So meaning what? Given me a set of points and giving me a set of lines in affine plane, you need to produce another set of points and lines for me. Okay, so how do we produce last time? Anyone remember? How do we produce a point in an affine, in a completion of an affine plane? Sorry. At a point of infinity. So what are in P bar in this case? What in P bars here? every point from P and also point at infinity. How do you define point of infinity? Sorry? Cancel. Okay. Cancel. Okay. So do we get the whole set? We just get the equivalent classes. Okay. So I have a dilemma here. I have a kind of notational dilemma here. Do you think I should write this equivalent class as a square bracket L or L bar? Both can. So you guys are open to both? Open to both, huh? Okay, then we will. Oh, is it? Do you use like alternatingly or you just use one of them?
I think more.
Square one?
Yes.
I mean, at first place when we introduce it, we can say that these two is the same, but whenever we want to use it, we just be consistent. Okay.
Yes.
You want the square bracket. Okay. Why I want the L bar is because whenever you look at the modular arithmetic, right? So usually we will put a bar 0, bar 1, right? For the equivalent classes. Okay, so sometimes you put a bar on your representative or sometimes you put a square bracket on your representative. Okay, so this thing is equivalent classes of tensor of parallel line. Okay, so somehow you include this line as a point, but you don't just include one line, you include a set of line and equivalent classes of line. Okay, as your point. How about lines? How do you define your line? How do you define your line? Sorry? So, scalar multiple point, what are you talking about? So what is the L bar you take here? What are the elements inside your L bar? Based on the line you had in your affine plane. Hmm? You need all the point of infinity. So that is one of your line. That's the line at infinity. Okay, so you artificially create a line that join all the points of infinity. Any other lines inside here? What are the other lines? Do I just take the usual line from L or not? Like that. Hey, check your notes, check your notes. Okay, so you don't just take the line in L, but you also take the line together with the equivalent class that it belongs to. Okay, because those are points already. Okay, we define those equivalent class as a point. Okay, so we add in an extra point into the line. Okay, does it make sense? Okay, so we see equivalence class as a point inside this completion here. Okay, does it make sense? Okay, what is the line? Line is a subset of points. Okay, subset of points. Okay, so maybe one definition you should keep reminding you is a line is just a subset of. Okay, don't think of a line as this thing already. Okay, what is this? This is made out by point. Okay, so when I talk to you about lines, don't think about just straight line, straight line, straight line, straight line. Think about collection of. Okay, does it make sense? Okay, so I put out a tutorial sheet, so try and do it. and then you can come and discuss with me. Depend on if I have times or not, I can provide you solution. If I don't provide you solution, right, maybe some of the tutorial question will be moved to your assignment question. Okay, yeah. So if you want to have a good practice, you can, once I give you a tutorial question, you can try and do it. And then if you're not sure or you want to check answer, tutorial can check answer, assignment cannot check answer, okay or not? If assignment check answer, what's the difference I marking your assignment? And there's no different already, okay? Tutorial I can check. Okay, so you can bring your tutorial, come in and check with me, and then, yeah, and again, discuss with me during my office hour. Okay, so last time we are stuck with showing that this completion is a projective plane. Okay, we haven't shown P2, P4, and actually P3 and P4 yet. Okay, P2, P3, and P4 yet. P1 we have discussed. I think P3 is obvious, right? P3 is fairly obvious, right? Okay, you can take the A3 to build your 3 collinear points. Okay, so the non-obvious one perhaps is P2 and P4 because they are quite new from affine plane axiom. Correct. Okay. In particular, P2 and A2 seems like contradicting each other. Okay, if they have to appear together. And actually, P2 is a very important property that we want in this projective space. Okay, in a projective space, two lines must meet at least one point. But in affine space, you could have a parallel lines. Okay. So what's the difference here? Basically, we just make the parallel line a point also in our affine plane. In this, I mean, in this completion. Okay, so that point of infinity should have a role here. Okay, have a role here, and it could justify why these points are called points at infinity. Okay. All right. Should you think a bit? Okay, I'll let you think for a minute first. Yeah, how are we gonna prove P2 and P4? I can try to discuss with your friends. I think P2 we prove it, no? No. Oh no, okay. 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 Then we'll do P2 and P4. P3 similar to A3. For information for this chapter, right? Although you will see me writing a lot of words, actually they are really just a picture. But you are taking this course. Okay, so you need to learn to write in words also. Where you should be able to draw, use drawing to think about it, and then you should write it down. Okay. Okay, so let's discuss about it. So let's prove P2. So any two lines meet in at least one point. Okay. Any two lines at least. Okay, so how many possibilities here you can discuss? So how to say, we have only two types of line, right? So we only have two types of line. So either you have two lines that you take from affine plane union with its tensor, equivalent class of a tensor, or you take the usual line with tensor, and then with the line at infinity, or you can just take line of infinity intersect with line of infinity. Which are these cases are obvious? Third one. So if you take line of infinity and line of infinity, you get what? So you get all the point of infinity. Okay, so you get all the infinity. Number two, obviously you get back your point of what? Set notation. Set notation. Oh, wait. Why? No. Everything, huh? So we got the line union with this point here. It's already a set of. So third one. Oh yeah. Sure. Thank you. Okay. Two. So what's this intersection here? What's in this intersection here? Okay, let's call Joel. Is it Joel? Okay, so what's the intersection here? At which point of infinity? L. Okay. Okay. How about two? How about one? Part one. What are the possibilities between this L and M here? What could happen to L and M if you simply just pick two lines? Either they are parallel to each other, either they are not. Okay. So if L is not parallel to each other, this means what? Huh? We are done. We are done. So if they are not parallel to each other, negation of parallel means what? Parallelism. There exists a point in common. Okay, so then they intersect in a point of A. Okay, so we're done. How about if L parallel to M? If parallel to M means what? Sorry? Their tensor is the same. So meaning their point of infinity is equal. They belong to the same equivalent classes of parallel line. Okay, so they intersect at the point of. Okay, can follow? Okay, no, can follow? Okay. All right. Let's go to point P4. What's P4? Let me get the statement. Every line contain at least three. Right. Okay, every line contain at least 3 points. Okay, I think last time some people talk about line at infinity first, right? Okay, so because we have two type of lines, right? So either you are a line from A and a union with the point of infinity, or you are the L infinity. All right, last time we talked about L infinity already. Okay, so L infinity, in particular, L infinity should contain at least 3 points. 3 points of point of infinity. Okay, so the claim is L infinity should contain at least 3 points of infinity. Infinity. Okay. So where do we get these 3 points of infinity from? Huh? Direction? 3 direction? Sorry. Where do we get the 3 direction? S, Y, Z? What do you mean by S, Y, Z? So where is it? Where is it? You say more than 3, you need to give me at least 3, where to find the 3? So we should get it from L should get coming from 3 non-collinear point. Okay, but sorry, yeah. So if you have 3 non-collinear points, right? Where do you get the 3 different direction? You just join the any two of them. Okay, they should give you different direction. Okay, they should give you different direction. If there's some direction is the same, what happens? If there are some direction is the same, what happens? They are calling here, yeah, sure. Okay, yeah, will contradict your assumption. Okay, if their direction turn out to be the same, then there will be a contradiction. Okay, to your assumption. Okay, I think this is a very important fact that you need to see it. Okay, any question? Live question? Question? 来，不用紧啊。What do you mean by more than 3? I mean, how to get the others, I don't know. At least 3, I know how to get. What do you mean? You mean change the angle like this? M, You mean like this? Also slanted, just become horizontal, right? No? You mean like this? You mean this? Well, I mean, how do we form this 3 line? You know, we don't simply connect them all. These lines are formed by P1. We get this line from P1. P1 says that any 2 points you can have a line between. Okay. So this slender line, I'm not sure exists or not. If got, then okay, but I don't know whether it exists or not. Based on the axiom, we don't know whether it exists. Okay, so based on axiom, sorry, we don't know yet. We don't know yet. No, the yellow line exists or not. Yellow line exists. Okay, but what we know is this 3 exists because of P3, and then the line exists because of P1. And then you need to argue these lines are not the same. If they are the same, these 3 points will become complete. Okay. Question? 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 Question 啊，来 question 不要等，来问题。如果问不出问题，不是怎样办？来 Jet， 如果问不出问题怎样办？怎样办？如果当下问不出问题怎样办？Okay, you can think about definition, you can solve it yourself, or 回去想一想，明天再拿来问。Okay 吗？ Does it make sense? Okay, so either you solve it yourself, okay, think back the definition again, or if you cannot solve it tomorrow, you bring it back again. Okay, so this have a discussion. This is a discussion. Only this is. Okay, any question on this question? Or you want me to write down the claim? Claim if L equals to M equals to N, or N. Can I say they are equivalent, or I just say they are in the same equivalent class? Yeah, let's do a general one. So our claim just now was if L has the same direction as M, or M has the same direction as N, or N has the same direction with M, L, then let's call this a name PQR. Then PQR are Collinear? This is what you claim, right? Just now. This is what we claim, is it? If either two of the line is the same direction, they should be collinear. Let's try and prove this lemma. See if this lemma correct or not. Okay. Even if this lemma is not correct, you should have some sort of prediction. Try and prove this lemma. So this is how we come up with tutorial fraction. This is how we come up with the exam question. So there's some details you need to fill. Okay. Any question? Still got question on this part? Okay, if not, we will continue to the general case where we take any line L in A. Okay, take any L line in A. First of all, this line, how many points inside this line here? It should contain at least 1 point. Okay, it must contain at least 1 point because it's a subset of points. Okay, should contain at least 1 point because this line shouldn't be empty, right? Okay, it should contain at least 1 point on this line. Okay, and see, look at this argument carefully. We're gonna build something from nothing here. Okay, we just start from a line, and then we argue that inside this line must have 1 point. But by P3, there should exist Q and R, okay, such that P, Q, R are non-collinear. Okay, such that these 3 points are non-collinear. If you cannot find it, right, then you can basically connect all the points already. And there's no 3 non-collinear points. Okay, so you must be able to find it. Okay, you must be able to find it. Well, so this Q and R, right? Then either 2 of these lines are not in the line, or 1 of them is inside there. Okay, so either Q in R or R in L. Okay, so either 2 of them is not in there or 1 of them is in there. It cannot be all of them in there, right? Because we assume that they are non-collinear. So let's discuss these cases. So if Q and R, okay, it's not in L, what happens? Can you imagine the picture? So you have a line L. You have a line L. Okay, this point is called P. And you have 2 other points not in there. Okay, so what can you do here? Here we could consider. Okay, so what's our goal? What's our goal? What's our goal? Don't forget our goal. What's our goal? What's our goal here? Every line has at least 3 points. So now you got P here, right? So you need to come out with another 2 lines. You need to come out with another 2 lines. Yeah, 2 points on the line. Sorry, 2 points on that line. 2 other points. Okay, but I gave you 2 points outside the line. Outside the line. Yeah. Yes. From P1, what do you have? P1 says what? Every 2 distinct points have a line connecting them. Okay. Wait, what are we doing here? So we want to find 2 more points on L, right? 2 more points on L. Okay, P1 tells you that every 2 distinct points you can connect with a line. Okay? Yeah. Okay, so how you use P1 here? Which one? There's another point on that line. How do you use P1? Can you tell us? How do you use P1? You want to use P1? How do you use it? P1 start with what? Hey, starting is very important. You cannot. Hey, you have 2 points, have a line between them, and have a line and then have a 2 points inside there. It's a different statement. You know, it's different, right? The order is wrong already. Wrong order. Our sentence got order one. 先来后到，要尊敬，好不好 ？Respect， you 先来后到。You have to come in, and then what's come then? It's very important. Okay, in Chinese tradition, we have this kind of teaching. You must Chinese. You must 先来后到，对不对？What's being said first is very important. Given two distinct points, only then I have this one. Okay. No, no. It's very different, huh? It's very different. Okay. So how what? But still, we should start with the P1 still because that's the only two you can do P1, P2, P3 only. Nothing else to do already. Okay. What can you do here? You got points, right? What can you do with points? Connect them. Connect them. Okay. At least there are three. I mean, there are three lines you can 3 points you can connect, right? Well, let's connect two of them. I mean, two of them with P. I claim that these two lines is very useful. Can you think about it? Why these two lines are very useful? Let's call this M. Let's call this. These two lines are very useful. Sorry? Both contain P, sure. Can you create the other 2 points or not with these two lines? There's not much thing you can use. You see, there's only 怎么我的4在3前面呢？这么神奇的。Okay, so you see, wait. Somehow the brain worked different way already. Never mind. Okay, so you see, only six axiom you can use here. Only 6 among these 6, right? Okay, because we use line from affine plane, so you should use A1 to A3 also. So we only have 6 things you can use. Huh? You already connect points using line already. What else you can do? Huh? 来 draw 来 You draw 来 draw 点 Yeah, use A2. How to use A2? Line parallel to M containing R. Okay, so you can draw another line from R that is parallel to M. And then you should use the argument that these two are different lines. So this L and M, okay, let's call it what? M1 or MR. Okay, this MR here should have a non-trivial intersection here. Okay? And then this intersection point should not come from P. Okay? Otherwise, it becomes a unique line again, becomes this N line again. Okay? So you have 2 points already, right? Okay, what's the other point? You can take again the parallel line on Q that is parallel to N. Okay, then you can create this 3 line. Okay or not? Yes, question? Wait, let me see. So Yiheng says that could it be these Q and R is one of the point of infinity or not? Okay, if it is one of the point of infinity, then it cannot be used. Okay, you cannot do. Basically you can if one of them is point of infinity, then you cannot apply A2 lah. Okay, this is the point here. Okay, yes. So we can choose non-collinear line from P A3, not Not what? Not P3. So where do we choose from? But now we choose from P3, so there's a problem. But if we choose from A3, we won't have a problem. Okay. So let's say we pick from P3. Okay, let's say we pick from P3. Okay. Okay, then I think we have a two version of this problem. So if I choose from P3, what happens here? Yes, I think one of the point could be point of infinity, but cannot be both of them. Right? No? Cannot be both. Can it be both of them? I think can. Okay, how about make that into an exercise? Okay, can we do that on P3 or not? Can we use P3 to solve a two? But I think to be safe, just make it A3 first. I scared there's a lot of case you need to look at here, but I mean, let's try it out. Let's try as an exercise. Can we use P3 to solve it? Okay. Should we discuss now or think later? Like what time is it? I think we think later. I scared not enough time. Okay. So let's make this an exercise. I can go back and think also. Okay, but if we use A3, this 3 points should be non-collinear very safely. Okay. Yeah. Okay. Yeah. So I won't write down the full argument. I just draw this picture for you. The full argument is in the lecture. Any questions so far? So far, any question? Yes. NQ is parallel to N, yeah. 没有，因为随便。哎呀，有时候东西意识到就好。嗯，我们现在只是讲一个 idea 吧。Because if you too restricted to this, okay, I don't want to argue. Just try for you. Okay. Okay, happy happy. Symmetry symmetry Okay. Okay. Yeah. Okay. Any idea? Any other question? So let's think about it whether can use P3 to solve or not. If it's interesting, then we can come back to this. If it's not interesting, I just leave it. Yeah, I'll go back and think about it. 有问题吗？有问题吗？谁要的结果？就是这个 P4. This one. Every line contain at least 3 points. 我们要 prove that every line contain 3 points. 嗯。我上去。Okay, yeah. 不是，翻了。我们是用第一个 P1. Two distinct points have a unique line between them. 或者 containing them. 只要你有2个点就要连在一起了，就可以连在一起。你等下找给我。OK，对。OK，yeah. Yes. What are you trying to do now? So let's say you say assume one of them is point of infinity. Huh? Yeah. Sure.
The NR have the same tensor N, right?
Sure.
Then we can use it, right?
Instead of using A2, instead of using A2 to get parallel line, get a parallel line from the same tensor and
Same tensor. Wait, what are we trying to do now? How are you trying to do now?
Find a new line which is parallel
To M,
and
which contain
R.
contain R. Okay.
Then use this line
Intersect with L.
intersect.
Okay. So why? Okay. Yeah. Okay.
This is
So you want to use different way than A2. Okay. So what's the way? Use tensor. But how tensor tells you there's another line? Who gives tensor the line? Isn't it A2? Yeah. Yes. Well, I mean, as long as you have a line, you should have a tensor already, right? Because you have at least one element inside there. How about the other parallel lines, how you create them? Exactly, use A2, A2 help you to create them. How many points you will have how many tensor. That's not on that line. Okay, so actually, these cardinality of points and line are very sensitive to each other. Okay, so that's why in the tutorial sheets, you will see that the number of lines and number of points, they are very related. There's a formula between them. Okay, you should try and do it. Check it out. In particular, there's one question says that any two tensor have the same cardinality. And then you can show that the cardinality of the tensor is equal to the number of points on those. Very sensitive on these points and number of points and number. Let's do this okay, I think there are still other cases, right? I think they are trivial, they are easier if Q is in L or is in L. It is easier. Okay. Okay, let's take a break. Let's break until 107. Okay, we'll resume. Can Jia Yi and 谁叫吗？新同学叫什么名啊？忘记了。你叫什么名啊？忘记了。泽瑞啊，泽瑞来一下。Jia Yi and 泽瑞 can you come here? 等一下，等一下。我看看我进去了。刚好你的1个小时没有给我增加任何工作量。他1个小时3分开说，你是忙什么？不然你这个进行的方向，
其他的老师哦，全部都不是一种人，聊嘞，然后来，这不是两个班，哦，你这学期是哪两大概？一直知道嘛，然后我也分享那边那个组长的话，说，所以你为什么不能跟你你只告诉我你把这个
这是什么来着？这个是什么来着？这个
他讲什么？但是我们叫他 recommend， 给 recommendation 的就还要填这个东西。
对，还可以。
不知道。哇啦！
他把这个东西，
没有，它好像是如果人家他写那个 recommendation letter 的话，他就会开这个表给我们评分，这多少分，这多少分，这多少分，然后低分的话就把这个东西送过去。recommendation 他是这样的，那这个这样的，他叫我们去把这些做好。
I'm very mature 我是一个很成熟的人，我是一个很 stable 的人。
所以所以他会发这东西到moodle上面，然后每次都要填这个东西。
没有啦，不是哦，是他只是给我们知道的那种细胞。
就如果你需要找他找 recommendation letter 的话，他就会拿个表格填他论文的分数，然后就拿给正式的。
我是那种很成熟的人，very mature 我敢讲。
怎么样很成熟的人？
就那种。
很焦虑。
所以
可以有70分在。
所以那个要证老师是要证明这个P3P4就是 online contain at least 3。
对，他是在证 A 的同学符合这个。
对，他是 A 的 closure 符合这个嘛？我不是我的想法是你应该分成3个 case 来讲。第一个 case 是你那条线是经过你，比如你有 DQ 啊3个勾，你要放在那。Case 1呢，那条线有经过2个点。Case 2那条线经过这3个点的一个点。Case 3这条线直接不经过任何一个点。
但是他的 argue 也成立，因为他的 argue 也成立，只是他没有解释为什么我有一个 P 以后，我一定会有另外2个点跟他们客户。
这个是 A， 这个是 A， 也是 A。
这只是说它存在的3点，他没有说一定存在每一个点都有2个跟他们现在。但是那个很容易秀。
那也不需要，因为你有 H 以后，你就一定有这 PQ 啊3个点。那么任意
但是我觉得就你这样的分类其实蛮我觉得比他这个复杂一点点，因为它只分了2类而已，一类是，因为我们知道 A 和 选里面就只有2类线，它这个分类讨论这2类线而已，它的那个 proof 是成立的。
解释不清楚，我感觉我们应该还算可以啊，只是没解释清楚。
没解释清楚，对。
这样
的话，你们2个会分开写。我们只是我们在用在那个网里面，这样标语保证了每个星期日找一次就够了。如果你们平时出来喝茶，因为老师告诉我你要选一个主要的告诉我，那么我们的这种操作对于我们怎么做下去，像其他万一不会好的，这都是写上去。现在的话，
卡在空地去标这个，
结果还是卡在这边的。那今天一两个，特别想下一个。
我会去吧，我说
所以不管你会还是不会，你只要也做在
举了一个那么写的话，就是2个这样的。
感觉还是怪怪的。
我这样，
所以我只要评估你，
我觉得这个我还感觉怪怪的，结果还不大，
我感觉还好啦，他那个方法还好，
我还不完全理解他这个是怎样搞。Q 不是啊，这个点一点一个 P， 然后就找一个 Q 啊。
对。
我 Q 和 R。
没有，先有个 P， 先有个 P， 然后摆 P， 然后摆那个 P 3，有 Q 跟 R， 都脱离了。然后就通过这样子，然后最后是 Q 跟 R 来找出另外2个。
对，因为你一定要平行线。
你每个星期都要进1个星期。
这两个 case 它没有完全没有点在这里。
所以到
但你这样哦，但你讲平线的话，就是你 Q 跟给那个infinity point。
它里面就不是比方用你因为这个T2了嘛，跟你两条线定了一个交点，这 infinity 也算交点。
是我知道，我知道了解。然后就是 A 度啊，你如果你就不能 A 度啊，
你不用放 A 度啊，不过我们证明了 P 度是对的吗？在我们这个 P 度对的，不用 P 度。
对啊，你不用 P 度，对啊，你是要 P 度啊，
不用 P 度。
但你要另外一个，你要找到另外一个线
啊，对，你
要找另外一个线才可以啊，你没有找到另外一个。
不需要，我已经3条线了。你看啊，我们假如我们已经把 P 度，
我知道你讲什么，知道你讲什么。
对的，是完全的3个点了。
这我知道你讲什么，只不过老师没听懂。
会做一个很大的东西，结果你就多点你，我预计你这样晚一点，比较晚的。我的建议是，因为完整的话才能够表示你已经因为其实世界上有太简单，每一个知识都把所以这是这个礼拜在有的是华为在主要考虑这个地方，我们两个哦，要不要唱歌？两个没有必要啊，因为不然这样的话，其实我会把主感的老师一个情绪，如果我有什么我会做 L， 因为我一要我所以如果我们对大家但你们需要我们做的题感是哪个？我想到一个我们先读吧，先读但是先有一个可以给大家是在了解的课题先，我们是礼拜我先时候每天看一下
你刚刚又有个地方没有套 set 来着。
还有什么？
我说你好像又有个地方没有套 set 来着。
没有什么？
没有套那个 set。
套那个 set。哦 ，OK。
周五需要跑。
哎，这是那个他说的另外一本书。
对，什么叫哪一面？
你是翻哪一面都是要。
没有在找一个东西看一下。
什么呀？
老师会这样辛苦啊，那个地方。
真的这样辛苦？
有什么
不懂哦，你有更简单的没？
这本书里面跟我想一模一样。
这本书有
E4 by A1 有2个点了嘛，一条线，然后再加上外线 infinity 就至少3个点哦。什么线哦 ？P 一定有一条，重讲 P 一定有一条线。
A1 只是过2点有一条线而已，它不一定说这条线上面就有2个点。
对啊，但是书也是用这样的。可是你证明了 P2 啊？如果你证明 P2 的话，那2条线在 P 区在那个 projective 区里面就一定有一个点。所以你直接能算几个平行线，就给它加几个点上去，就每条线就3个点了。
什么意思
啊？解释。我的证法，
你加解释啊。
我的证法和别的不一样。我的证法不一样。我这里写的那个，我的方法是这样子。看到我们知道3个点嘛？对，我们就分3个 case 嘛。对，第一个 case 就是假设是过2个点的 P 区的，第二个 case 是这一个过1个点。对，还有其他第3个 case 1个点都没过的。对 ，OK。 一个点都没过了呢，它的第一个点就是这一个和这一个的交点，第二个是这一个和这个的交点，第三个是这一条线和这条线，所以这个加上。
比较激动。
对，
因为两个线另一个点。
没有。
这一边的话呢，它就是第一个点是这里咯，
这样激动。
第二个点是这是老师刚刚做了，这一条跟这个点的平行线。
我是
没有，我要感动，
我是讲这个平行线是你会和这里交叉吗？
对，交叉对，交叉。
就代表 by A3 again，它这个三个是
什么
扣零，像这个
没有，可能我有一点赶，
是扣零，
所以我会比较激动一点。
它不会是扣零的，因为如
挺好的呀，它一个小时没有加任何。
如果这三个点扣零的话啦，或者你就能证明这 PQR 扣零的。
这是 PQR 就是扣零。
后一个小时没讲什么？
如果你的
PQR 是 non
PQR 是 non collinear 的，对
对对。
如果这个点是重复了的话，你就能从这一边，
对，
你就能证到 PQR 是 collinear，那么就矛盾了。同样，这个也是，这个点也不可能是任何一个，因为如果这个点是任何一个的话，就这个是一条线的话，那么 PQ 这一个是一条线，它又是 collinear，所以这一
解答了。
那我们只要确保这两个点，这个两个交叉哦，因为是
什么东西？
对，
他们没有，他们没有问我，他们没有。我在讲东西。
只是这个课本里的是用，他讲你拿一条线，然后你把 A1 和两个点。
这本我没有看，我感觉
他们是这样跟我讲，
这本我没有
因为
看。
我以为的是一个三条线打到里面，所以他们这三个点他们不会在身上。
不一样。
这条线你这条在这个点，你这条这个点，随便的这个点加 P 加这个点，它三个在同一条线。
什么？你要两
我这样讲，我的
要么
错。
很烦恼。
你再讨论一下，然后下个礼拜
我以为是三个点在同一条线上，这个它是三个点。
难啊，不对。
错。
比如是人做的，因为我看到 Mechanic Cross 的。
哦 ，OK， 哎，那个好玩的，那个你应该要做那个。
8条哎。
我叫8条。
8个。
5个吧？啊？有看错东西吗？
看到一个人是他自己狂抛下来，他还要给
ADE 吧？不是 ADE 吗
ADE？
对啊 ，ADE 啊 ，ADE。
我去。这种。
没有，我要是
什么？
就是你刚刚说就是 OK， 我确定一下这两个东西我没理解错啊。这个你是想说这个东西是这两条一定是平行嘛，对不对？所以这个点跟这条线是不会有任何接触嘛，是不是？对。然后你讲说这个是它不管任何一条线，它一定会有。讲好
P2 什么 ？statement 什么 ？P2
两线一定一个点，
两个线一定要有一个点，
有那个点，
两个线会相交在一个点。
对啊，parallel
两条线会相交在一个点。假设这两条线丢在这边的话，它就相交。
相交在那个。
为什么它是 parallel 到后面还会相交？
因为我们在 P 里面加了 point，
不懂，我们就让它交吧。
我
们就让它交，我们就是让它交，不然的话就同一个东西啊。为什么我们要define新啊？如果是一样东西，我们就不可能叫它新的名字，它肯定是不一样东西嘛。
所以我们要假设两个平行线后面会交于一点，
交于一个无限点，交于一个无限点。
OK，
其实我们做得到吗？做得到，我可以做到给你看了啊。就是来，因为我们的线是，它不是线吧，它是线加上它 belong 的那个 direction。
对吧？
你可以看，如果哪一个平行没有相交的，但是你看一下，我也拿它的 direction。问题是哦，他们是两个 parallel line 呢，这样这两个是不是要等于啊？这样他们有一个同一个点呢，它是不是相交了？我刚才就证给你看这个。
Pencil parallel
啊，你想一下，
一个很好玩的 A 的话，通常直角坐标系上 A 是一个直角坐标系上的。
你可以直接写在文字，你直接写在文字，写。
那不 complete 了。这 A 的话，如果是在这个 affine space 的话，它是一个直角坐标系上的一个点，所以全部都是有限的。你把它给extend 放大成一个 P 的话，你可以把它想象成是一个直角坐标系上的点，加上所有的 points at infinity， 然后 point at infinity 就是指这一些 这一些方向，这些方向都是一个元素，是这个点。所以呢，这两条平行线是交于这一个方向，这一个方向的东西。
你可以画很多都会交于同样的方向，对吧？
然后这些就是判写权，我这样思考。
可是交于同一个方向嘛？可是那个点要这样解释？它
那个点
就是一个已知的
点是一
刚刚你
个
画点就定义出来的点，
我们是定义出来的，我们定义出来的，我们叫它新点。
想一下这两
虽然我们有
这两条线永远都在，他们就
真的
接于这个我们叫这个点哦。
OK，
因为这个
我们是加进去的，我们加进去的那个点。
我们的每一条线上面都加了一个它的那一个 direction 的这一个，
而且这个东西我们叫点，新的点了。
我们就加了这一个嘛，这个就是这个 direction 的意思，这个
direction 也是个点，
这个 direction
它就是个点，
我们教的，我们 define 的，
就是我们定义它是个点。
那个点在哪里？你要有一个方向嘛。
OK，
对，我们定义，因为点本来没有方向嘛，对不对？所以我们把方向新增为一个新的点。点本来没有方向的，像我们把 line 的方向也叫做点。
后面没有
不也？OK，
太短了。
有没有？我本来不要答应，我怕前面会跑起来。OK， let's continue. Let's see. Okay, I think what I written before there's some problem, but we're gonna change it on the spot. Okay. So well, so we can take, so we'll take the right hand side here as a definition of a abstract projective planar. Okay, as long as you have a double of points and line, and then you satisfy these property here, you will be a projective plane here. Okay, so one thing you need to note here, it is a bit counterintuitive. 比较不自然一点 is when we go from affine plane to projective plane, right? The points you consider is not just point anymore. Okay, point doesn't have direction, but you make direction of lines into points also. Okay, so this is a special point here. Okay, initially the points has no direction, right? So you just stand there. But now you include direction as your point, okay, in projective space. And then how any lines can intersect exactly is at this direction. Okay, they intersect at the direction. Okay. Because parallel lines shouldn't intersect. Okay, but if their direction is the same, we call the direction as a point, then they intersect at that direction because they have the same direction. Okay, so there's the same point. Okay, understand? Yeah. Okay. I think it's better I start with a definition of a line first. I think we talked about it last time, but let's talk about it again. So a line in P2K, okay, a line in P2K is the set of points. Okay, it's the set of points P such that A0 S0 plus A1 X1 plus A2 X2 equals to 0. Okay, so what are these A0 X0? I need to say clearly here. So P here actually is the S0 X1 X2 here, and then such that I should fix this A0 A1 A2, right? Shall I fix it? So if you are given a line, we will fix A0 A1 A2, okay, such that these A0 A1 A2 are in K. Okay, but did you recognize what's this equation here? Actually, this is a plane, right? Right, this is a plane in R. I mean, okay, let's say K is R, like we can draw R only. So in R3, this is a plane in R3. Okay, basically this is a plane in number 3. Okay, so a line in the projective space 2, right, actually is a plane. So let's draw it. Why is it a plane? Can you justify from a linear algebra sense? There's 3 variables in one equation. So the null space is, if this is non-degenerate, okay, talk about non-degenerate case. I don't talk about degenerate case. Non-degenerate one, this should have a dimension 2 null space. Okay, so this 2 dimension, right? Two free variable, right? Right or not? So if you want to solve this S0, S1, S2, right? We are row reducing 1 times 3 matrix, right? Okay. Okay. You only have at most 1 pivot. Okay, so 2 variables have. Okay. Okay. Well, I mean, last time I give you an example, right? Okay, let's you have an example to think about it. If you look at x plus 2y minus z equals 0, right? Okay, if you find the parametric vectors to this solution, right? In the new notation that we had is this, it is spanned by these 2 points here. Okay. Spanned by these 2 points here. Okay. So it is a span of these 2 points. Yes, this is your. Okay, but let's say let's say let you think about it. If I go to P1, we prove that it is all lines going through the origin right in R2. Okay, how many planes inside there? One plane. So meaning what? There's only one line there. There's only one line. Okay. So in P1 we only have one line. Okay, right. Let's see. I think I need to add one more proposition here. You should be able to show that PK2 is a projective plane. Okay, that satisfy all the axiom. Okay, using the homogeneous coordinate definition that you have. Okay, and then prove all those axioms. Like how you prove it for completion of affine space. Okay, and then next thing is we want to show that actually how we get PK2 is we can complete our affine 2K. Okay, we can complete this. But what's the isomorphism here? What's the isomorphism used here? Obviously, it has to be a bijective. Okay, transformation 1-to-1 and onto map. There's one more extra condition here. It has to send collinear points to collinear points. Okay, so this is the extra thing you need to check. Okay, if you want to show that 2 projective plane are isomorphic. Okay. Well, how about let's discuss it. Let's discuss this. So what's the map we need to use? Maybe we don't write in full, but we will discuss what's the map we need to use. Okay, what's the map? What's the 1-to-1 map that define the projection here? Okay, so to discuss about the map, right, you need to know how the elements looks like. Okay, you tell me where all the elements go. Okay, in P2K, what's the elements here? It is the 3 tuple with the column. Okay. Then where should these point go here? Do you build A2K again? Okay, from last hour, how do you build it? How do you build A2K? I mean the completion of A2K. How do you build it? Obviously, this guy contains A2. What are the points? Okay, in other words, what are the points inside the completion of A2K? What? Huh? One of them is pencil, and then the other one is the points in A2. Okay, so there are two type of points here. Okay, so how do you cover that two types of point here? Who should go to the ordinary point? Who should go to the pencil? Huh? What do you mean by divide? Can you tell me the formula? Sorry? Who want to try? Tends to what? A's, huh? Which one? A0 divided by A0 divided by A0. And then you mean like this? So you mean you write, okay, you pick a representative like this. You're saying this, pick a representative first. Okay. But can you always do this for every point in P2? Can or not? When can you do this? When A0 is not zero only, you can do this. So you want to put extra condition now. Is it? Okay, so let's write down what you want. Okay. So if A0 is not zero, then we can pick a representative for this point here. And then what do you do? What do you do with this point? So we can just pick up the two coordinates here. Okay. This is the valid map, right? Because the two coordinate points should be, the two double points should be living inside A2K. Okay. Actually, it suggests on A2K. Very not. It suggests. Okay. You can get the 0, point also, right? Origin. If A1 is 0, A2 is 0. No better as A0. Okay. But how about the other points? What do you do with the point A0 equals 0? Where should they go? You have not much choice already, right? If you want to build a surjection here, you already cover every point in A2 already. So now you need to cover the point at infinity. So how to cover those points? Sorry? 0, 1, what do you mean 0, 1? 0, 1 like this, 0, 1. Point of infinity, what are them? Just now we said already. They are direction. How to take direction? No? Hmm? Huh? What's divided by A1? If A0 is 0, and then send it to. Okay, so let's write down the equivalent class first. Then we will pick the equivalent class as 0, A1, A2. Okay, so next, what do you want to do? Any idea? So you send to the point of infinity. Send to the point of infinity. Wait, let me think. Send to the point of infinity of the line passing through this, passing 0, A1, A2. Like this. Passing 0, 0, 0. Doesn't matter, right? Because point of infinity should pass. I mean, the line. Let me think. Does it matter or not? Does it matter? So this is a line, right? So this is a line. At the same time, it contains 0, A1, A2. So let me think. What I mean doing here. Okay, so well, I mean, should we draw it? Let's draw it. Wait, let's draw it. Let's draw it. Where are the A0 not equal to 0? So let's put these X, Y, Z out. So if A0 is 0, meaning what? You're looking at the ZY plane, YZ plane, correct? You are looking at the ZY plane. Okay. And then you have to decide where this line go. Okay. And then we should send this line to the point of infinity, X point of infinity. Correct. Okay, so these points are labeled by A0, A1, A2. Okay. So, well, I mean, shouldn't we just let me think. Shouldn't we just write it like this? This enough? Say again. What is A2? Who is mapped to A2? I'm mapping to A2 bar. So what's the line in A2? 0. It's a line in A2. Is it a line in A2? Is it a line in A2 or not? Is it a line in A2?
I think to write A1 column A2 showing line.
Oh, you mean the okay. So you mean just use A1 colon A2 will give you a direction in ZY plane. Is it true? You don't think so? Sure. But I mean, this notation should contain the 0, origin, right? This is already the line containing A1, A2, and 0, right? Correct. Okay. We just send to X pencil. We send it to the direction of the line. Yeah. Any question? Any question? Question? I'm not meant to confuse you, but you need to ask question. Yes. Yeah, yes, that's right. You are correct. That's right. Yes. OK， 没有错。因为 A to bar 就是一个方向加上点啊，对啊，没有错。That's right。没错。You are right。对，没有错。对的东西要抓稳一点，不会的东西才要去挖出来。Okay. Any question? No question? Okay, so what's left to show here? You need to show that this is a surjective map, and then this is a one-to-one map. Okay. And then send a collinear point to collinear point. Okay, let's skip that. I'll put inside my notes. A fairly straightforward check. Okay. And then so left to check here. So one T is injective. Second T is surjective. And then third T send collinear point to collinear. Okay. Okay. Next is a corollary. The corollary here is very interesting. So if you look at this isomorphism here, what does it tell you? You can see that a straight line in A2K will extend uniquely. Okay, will extend uniquely to a projective line in P2K. Okay, and then what it follows here is another corollary. Any two parallel line in A2K actually intersect at one point. Okay, at one point in P2K. Okay, just now said at least one, right? Is it P2? Let's see. Yeah, just now said at least one. Now it just says that one. Okay. Okay, I think this one correspond to answer what Adrian and Rachel present in the reading seminar. Why the two parallel line intersect? Okay, any question? Any question? I think the proof is fairly easy. I just leave it to you. I'll provide the solution. Okay, any question? Question before we proceed? Okay, so projective plane is meant to be different from affine plane, so don't be confused. They are meant to be different. Okay, before doing algebra, I plan to do this first. So it's the Dersauges theorem here. I hope I pronounce it correct. Dersauges theorem. Actually, this is called P5. Okay, so why we call it P5? Because this shouldn't follow from P1 to P4. Okay, so this is a new property here. So what's this new property? It's very geometry. Okay, it's very geometry here. So should I just write down the? Okay, I think I just draw it for you instead of writing long word. So basically, you start with two triangle. Let's call it A, B, C like that. Okay, and then the other triangle, call it A prime, B prime, and D prime. Okay. So what can you do is you try and draw a line, okay? Draw a line joining AA prime, CC prime, and BB prime. Okay, draw it like that. And you extend it. Okay, you extend it. Extend, extend, extend. Okay, extend it. Okay, can follow? Okay. Well, I don't want this picture, so let's draw the other one. Oh, let's draw this tree line like this. Hey, sorry 啊，你们不要跟着我抄先了。Okay. So let's say if this tree line intersect at one point, okay, let's say it intersect at one point. Okay, and then let's get our triangle again. A, B, C, and A prime, B prime. Okay, if the tree line that you create here intersect at one point, I will call this point as a center of perspective. Yeah, I think this is the perspective that bring out in the reading seminar last time. Perspective, center of perspective. And then we will call that these two triangles are perspective from a point. Perspective, right? So basically, if your eyeball put at O, right, you can see like the other triangle are in the vertex of the triangle are in the same line with the first vertex of the triangle. Okay, so this is perspective. Okay. So if you can do that, what's the other construction you can do? The other construction you can do is you extend the edges of your triangle. Okay, so for example, this AB, right? You extend it. Okay, extend your AB. Extend your AC also. And extend your BC as well. Okay, extend it. I hope I'm drawing it okay. Otherwise, this theorem maybe doesn't work. I don't know. But okay, you do the same. Okay, you do the same. Okay, what do? You extend A prime, B prime. Okay, prime, B prime. You extend A prime, C prime as well. You extend B prime, C prime as well. Okay. Can follow? Okay. But now you see the perspective way of looking at these two triangle, right? You kind of pair the A prime together, B prime together, C and C prime together. Okay. Similarly, you should pair the pair that connects AB and A prime, B prime together. Okay, so in particular, you can look at the intersection of these two lines here. Put it one here, AC and A prime, C prime, and also AB and A prime, B prime, and also BC and C prime, B prime here. Okay. Okay, I think this picture a bit not accurate, but they're meant to intersect. Okay, they're meant to intersect. After the intersect, right, there's a very interesting phenomenon. You can join the 3 point of intersection, and then they should live on the same line. I'm not sure why this theorem is sometimes a bit hard to draw, because I haven't really looked very close into it. But if it is a theorem, it should be easy to draw. But anyway, I drew a successful case here for you. So it should be like this. Okay, so if it is perspective from one point, right? Again, those edges, elongation of the edges should also lie on the same line. Okay. Okay. Makes sense? Okay. So the motivation was you can create a space that has P1 to P4, but not P5. Okay, we won't do it in this lecture. I'm not sure whether we want to do it in tutorial or not, because It's quite long, depends. But I won't ask you to do it assignment. Okay. Okay. Okay, can get the picture. Okay. And then we will call this line line of perspective also. For this line of perspective. And then these two triangles are said to be perspective from the line. Okay. So this theorem will say that if your triangle is perspective from a point, it will be perspective from a line. Okay, this is the theorem. Okay. Okay. What time is it? Okay, let's quickly go through. I don't want to spend much time on this part here, but I want to show you this very interesting result. We don't want to dwell time on here. Okay, let's show you this interesting result here. So what else we need to see this P5 here? Let's show you more definition. So this will motivate projective tree space. Okay. So if it is, so we define 3 points to be coplanar if they live on the same plane. So we will prove this theorem in P3 first. Okay, P3 first, and then we will deduce it in P2. Okay. So what is difference about P3 and P2 here? Okay. So in P3 here we have triple already. We don't just have plane. We don't just have line. We need to define what are the plane. Okay, in P3 we have a set of plane already and satisfying 6 axioms here. Okay, so the goal here is this 6 axiom will guarantee the Dersauges theorem. Okay, this 6 axiom here will determine the Dersauges theorem. So what's the 6 axiom here? First one is very familiar to you. 2 points must have a line joining them. S2, 3 non-collinear point line on a unique plane. So this is specially catered for P3 because we have plane already. Okay. S3, a line meets a plane in at least one point. Okay, so this one talk about what's the relation between line and plane. Okay, and then S4, 2 planes have at least one line in common. So this is a bit like what we had just now. Any 2 lines have a line in common. Any 1 point in common, but now it's 2 planes have 1 line in common. And then S4, there exists 4 non-coplanar planes. Okay, so none of the 3 are collinear. 4 points cannot live on the same plane. Where previously said 3 points cannot live on the same line. And then last one is every line has at least 3 points. So this is very similar to what we had just. Okay. So surprisingly, with this 6 axiom here, we can prove the Dersauges theorem. Can we prove it? We need to prove some more properties, and then we will see that the Dersauges theorem will work for the projective tree space. And then how do we deduce? The problem is how do we deduce for P2? Although it doesn't work for general projective space, right? It works for P2 actually. Okay, it works for P2. Does it work for P2 or work for any plane? Let me see. So yeah, it works for P2. Okay, it works for P2. I think we don't have much time. Yeah, let me see. I want to bring this theorem to you, but I think we won't do it in much details for this theorem. I want to do a disclaimer here. I won't do much detail on this theorem here. I just include it for the sake of completeness or to motivate what's the next level of projective space. Okay, and I think we won't do much assessment on this part. Okay, but I urge you to read about it because we want to build your intuition on projective space. Okay, but what you need to learn from this geometry section is you need to know how to manipulate axiom. Okay, to build you a line, build you a point, build you anything. Okay, I give you a set of axiom. Can you build a plane or not? Can you build a line or not? Okay, can you check that these 2 lines have intersection or not? Okay, so this is the objective of this chapter. But this Dersauges theorem, I think, very sad to say, I think we don't have time to look at it because I don't want to spend a lecture on this thing because we won't test it also. I mean, we won't like, I mean, it's very technical, but I'm not sure how it's applicable to other things. But at least from what we do in the geometry part previously, we are trying to play around with axiom. Okay, this is the point I want you to get. Okay, for this geometry part. Does it make sense? Okay. Any question or not? Yes, yes. Oh, you mean okay, sure, okay. Oh, you mean even though it is not straight, it still intersect at line infinity. Okay, sure. Sure. But I also cannot prove to you whether they will intersect. Wait. So wait, you are claiming something even stronger, is it? This one. This one. Well, I mean they should. I mean they. Let me see. I mean they are not parallel, right? I think they should intersect at some point. They are not parallel, right? I think clearly not parallel, so they should intersect at some point. But I'm not sure. I haven't really looked into it. Like what is the thing I done wrong, or what's the thing I need to consider much. But yeah. Huh? Question? 可以，但是 like 我就是想要解决不 parallel 的东西嘛。可以 obviously 可以。But yeah. Okay. Any question? Any question? I think you won't see this in your assignment, I guess. But and test also. But I want you to appreciate how important are axioms, how we decide these axioms, and then if we don't have these axioms, what do? We go look for new stuff. This is the moral. Okay, and then for this part of geometry, I want you to know how to manipulate axiom. Very important. Like just now, right? If you read the axiom wrong, then it will get you a wrong concept. Yeah, very important. It's very important. Yeah. Typically, why students confused about maths, why they hate maths, right? Because they read wrong. It's just as simple as that. If you read it correctly, you will think the same as well. For sure one. For sure. Okay. But some of the people, right, they don't know what is wrong about them. About 自己错在哪里. Okay. So this is a very important thing to check. Okay, no? Yeah. Okay. Yeah. How to check? So that's why I asked you to do a group project. Your friend can check you. You can check your friend. Okay. But don't score them. Okay, so see you tomorrow.
我觉得李浩经常表达的是就在1、2让它平行，这个 theorem 也不成立。
那个我知道，但是问题是不知道每次来没有画。